Good morning. Welcome to our e-learning day. So this is Tuesday, January 16th. So what I want to do this morning is just walk through the notes and some of the practice problems that I asked you to do on Friday when we were home again for our e-learning day. So here we go. So we have Molarity, a how-to guide. So you'll notice that I went ahead and highlighted a few things. So if you have your hard copy, you may want to do the same thing. All right, so we are looking at molarity, and this handout is going to introduce solutions and one of the most common mole-based units used to describe them, and it requires a mass mole conversion. So we're still using the stoichiometry that we learned in Unit 4 throughout Unit 5. So first of all, a solution is a homogeneous mixture of two or more chemicals. If we look at the diagram or the picture on the right, um, solutions involve a solid solute, so salt, sugar. For most of what we're going to be doing, they're going to be ionic compounds, and then a liquid solvent. The most common liquid solvent is water. It could be alcohol, depending on what your solute is that would dissolve in there. So then your solution itself would be salt water. So a couple things to consider when we're looking at a solution, which we call an aqueous solution, so something dissolved in water. So there are several ways to express concentration. And the most common way is to use molarity, which is what we're going to be doing. So if we look at the picture to the right, you can see how we have a darker red on the left, and then it gets lighter and lighter as we go off to the right. So as we look at molarity and we talk about how concentrated something is, we don't want to talk about how strong. The term strong goes with acids, and we'll talk about acids a little bit later in the year. But strong is a term that we would use for a strong acid or a strong base, and that has to do with how many hydrogens are released. In molarity, we're talking about how concentrated it is. And just think about this picture that we see on the right side. All right, so as we go down, we're going to be expressing the amount of solute in moles rather than grams, since we can compare moles more readily. Remember that a mole is a certain number of molecules or particles. It is what a chemist would say equal amounts of two chemicals we want to equal moles. So the units of molarity are moles over 1 liter of solution. So in the denominator, we're expressing volume of solution. Makes it easier to measure out the proportions. Molarity is commonly abbreviated with a capital M, and a capital M is important because remember, if we use a lowercase m, we're talking meters, and in this case, we want to know that we're looking at something slightly different, so capital M. So in these problems, you usually need to expand molarity or big M to moles over 1 liter. Or explicitly, we're talking about moles of solute. You know how I like to use the substance as well here as well, over 1 liter of solution in order to recognize kind of what's going on. Okay, and if we look at that moles of solute over 1 liter of solution, it should look familiar, looking like a conversion factor, and it is. It will help us get from moles to liters of solution, how much mass eventually would I need to put in. So this conversion factor is something that I do use and have to use whenever I'm making up solutions of certain concentrations. So when you're making a molar solution, the key in making to the solution that you described in molarity is to understand the term. So in terms of molarity, it tells us what to do. So if we have 0.25 liter, if we wanted a 0.25 liters of a 3.0 molar solution of sodium chloride, we would take what we want, which is the volume, so 0.25 liters of sodium chloride solution. We multiply that by 3 moles of our solid over 1 liter of solution. Okay, again, we're breaking up that big M into its moles over liters, and we get 0.75 moles of solution. So if we look, our problem looks just like the conversions that we were doing, excuse me, in Unit 4. So let's scroll down here. So we've got a few more examples, and I'm going to run through a few of the examples uh, at the end that you did the work for. So I'm going to skip over a few things at this point. Okay, so actually, no, I'm not. We're going to go back up right here. Okay, so if we take a look at the next part of this example, so we're still working with the 2.25 liters of sodium chloride. Now, to get moles is great, but I don't have a balance that measures the number of moles for substances, so we always need to convert to grams. So if we need a 3 molar or 0.25 liters of a 3 molar solution of sodium chloride, I need to figure out how many grams I'm going to be adding to our solution to get to what we need. So again, we're going to start with what we're asked to find, which is we're asked to make the 0.25 liters of solution. Multiply that by the molarity. We're looking for 3.0 moles of solid sodium chloride over the NaCl solution. Okay, so the solutions, this would cancel out with our solution that we're beginning with. Then we're going to use the molar mass of sodium chloride, so 58.44 grams of solid sodium chloride, and our moles would cancel out, and we would need to add about 44 grams of solid sodium chloride to get to the volume and the molarity that I'm looking for. So if we take a look, we're combining the two steps, so lets you see the whole problem and what's going on all at once. We certainly could do it in two smaller steps, but we're going to be doing it kind of in one longer problem. This also avoids possible accumulation of rounding errors so that we're not rounding too many times too soon. So if I go to 2 sig figs and then 2 sig figs, my answer might be off just a little bit more. It encourages us to combine steps and then calculating only the desired final result. Okay, and as always, we want to show clear work and show what we did as we went along. All right, so if we take a look, molarity is a small extension of previous topics, as I have mentioned. You know how to interconvert grams to moles using our molar mass, and you know how to use dimensional analysis that lets you go from units to guide you throughout the problem. And the only new part is the molarity conversion factor itself. So molarity is conveniently described as a combination of familiar units. We know, and he used the term moles already, so moles of solute over liter of solution. So you're going to use that information or definition and your background with units in moles in particular, and you'll be able to complete the molarity problems. Okay, a couple of things to keep in mind, and I've mentioned these already, but be careful when with units and then their abbreviations. If you're going to abbreviate moles, I typically don't, but you can. The abbreviation for mole is MOL. Molarity is a unit of concentration, which means it's moles of solute over liters of solution, always a big M, or you can expand it and put moles over liter. Mixing these up can always cause us some problems. And then remember that a lowercase m has nothing to do with this because lowercase m means meter. And then there's a metric unit that's abbreviated m with millimeters, milligrams, milliliters. Okay, so down below we have our practice problems. And so what I did with each one of these is at the very end, so if you scroll down to, if we can get to the end of our problem document here. So here are the numerical answers. And then I took the time the other day and we have added on our work. Okay, so if we take a look at some of the answers, so I'm jumping down to number 3. So what I did, I listed in the upper left-hand corner the information that I was given. So I was given a 0.500 liters of solution is what I was looking for, with a concentration of 0.100 molar, and this is for magnesium chloride. So with magnesium chloride, I need 95.21 grams per mole as my molar mass. So this right here is my beginning information that I have on the kind of left side of my work here. Then I have my expanded molarity. So big M equals moles over liter. And then I'm saying mole is equal to X. And I do this because we have so many M's and big M's and little M's and L's. And those are units, not variables, when it really comes down to it. So I use moles is equal to X so that I can use an X to say and to solve for that. I think it's a little less confusing, I hope. All right, so all I've done here, if you look where my cursor is now, moles is equal to big M times L, which is liters. So I've just rearranged my molarity unit so that I'm solving for moles. So then I say X is equal to my molarity 0.100 moles. I'm expanding my unit over liters times 0.500 liters so that my liter unit cancels out and I get X is equal to 0.0500 moles. All right, so from there, I just took my number of moles because, again, I don't have a balance that would measure that kind of thing. I then use my molar mass of magnesium chloride, 95.21 grams. I did not put MgCl2 here because I just didn't have enough space to write it all. But you can see I concluded it at the very beginning and then in my final answer. So my moles cancel out. I end up with 4.76 grams of magnesium chloride is needed to add and create my 0.500 liters of solution. So that's kind of what I did throughout. So the difference between 3 and 4 is that our unit on the bottom always has to be in liters. So if you're given milliliters, we want to go ahead and convert that to liters right away so that we have the correct unit. So molarity always is moles over liters when we break down that unit. So again, I have written down the information that I'm given in my problem. We're looking at sodium bicarbonate here. So I'm looking for a 4.00 molar solution. I only need half a liter, so 0.500 liters. My molar mass of my substance is 84.01 grams per mole. Again, here is my molarity. I've expanded the units to show moles over liters. I'm going to use X as the variable to represent mole. So I get X equals big M times L, and then X, solving for moles, 4.0 moles over liters, multiplied by my liters, 0.500. My liter unit cancels, so I end up with 2.0 moles. Oop, and I didn't put my answer here, or my substance of my sodium bicarbonate. So again, I need to get to a unit that I can actually measure. So I'm going to use my 2.0 moles of sodium bicarbonate, my molar mass, and I get a final answer of 168 grams of the sodium bicarbonate. All right, so the next several problems, I believe we're really doing the same thing. 5, again, you got to go 2 liters. That's a must. Let's take a look and see if there's anything different with my work as we go down. Number 7, not much has changed. Number 8, I don't think we're looking at too many changes there either. So each of these problems are really looking at the same process every single time. Let's go down. Number 10. And you'll notice each time I did this, again, I wrote down what I have to begin with, what I'm asked in the problem, what conversion factors I'm going to use, my moles over liter, so I can see how I'm going to solve to get to the moles and the information that I need to keep going. All right. Number 11 was a play on number 10. And the difference between those two problems is number 10, we're looking at a substance without water in it. And then the other has water. So it's really the molar mass is the only thing that's different. So my work would be the same. I'm just changing the molar mass to 294.10 grams to account for the additional mass of adding 2 water molecules on. So each water molecule is 18.02 grams per mole. So adding 2 of those onto my total mass, and that's where I get the 294. And then the work itself is going to look very similar to what we did with number 10. Okay, so number 12 is asking us how many moles of sodium ions are in our 1 molar of solution. So in a mole of sodium sulfate, Na2SO4, we can take a look and say that there are 2 moles of Na, because I've got a subscript of 2 there, for every 1 molecule or 1 mole of sodium sulfate. And then sulfate ions, I would have 1 mole if I were asked that question. All right. Okay, so then we just kind of keep going down below, and you can see where we're looking at grams and getting 2 moles in the end. Okay, and looking for our final volume. So when I'm given a mass and a molarity, I'm going to solve for volume instead. Okay, so you can see I've got 1 liter. I didn't put Na or a potassium nitrate for number 14. I could have put potassium nitrate solution. I don't want to put that I'm looking at my solid. Okay, so that's why I didn't leave a substance above where it says 1 liter for 14 or 15, because I'm looking for the total solution, the amount of water, and the water and what my solute would be in the very end. All right, so those last few we're just solving for volume as opposed to our mass, which is what we were doing before. So if you look, we're using the molarity. I'm looking at 15 now. So if I have 0.15 molar solution of iron to chloride, in this case, I'm given milligrams, got to go to grams. So my grams, I can get to moles. And then once I'm in moles, I'm able to use molarity as my conversion factor, flip it so I can keep my volume unit and get rid of my moles. And then we are all set. All right, so we can take a look down here. So as you go through, so take a look at kind of what I have written, make any adjustments that you need to make. We will take a look at this tomorrow. I do want to see kind of how we're doing. So I am going to ask you, as kind of originally planned, to do a checkpoint for me. So I'm going to give you 1 question based on this worksheet itself, asking you very similar type questions just to see kind of how we're doing, since I haven't seen you since Thursday. Okay. All right, so at this point, this was the e-learning work that I wanted you to do for Friday. Then what we're going to be doing is we're going to move on to kind of what I need to do for today. All right, so if you have questions, I will be on the Google Meet during our class time, which it's a late start, so it's a little bit later. And right now, I don't remember exactly what time that is. So just check back during our late start time if you have any questions, and I'll be on that Google Meet.